Okay, so how do we find the area of a circle? Okay, pi r squared, which in this case is pi times 15 squared. And what does that give you? Okay, say it again. Okay, area of a trapezoid is base 1 plus base 2 times the height divided by 2. So what does that give you? It gives you 49 square yards. Okay, area of a square. What's the area of the square? 8 times width, 8 times 8 is going to give you 64. Okay, on a parallelogram, just base times height, so 16 times 9, which is what? 144 square feet. All right, what's the area of this rectangle? It should be 32 square inches. And then for this triangle is base times height divided by 2, which is 35 square yards. Area of just a single two-dimensional shape like this trapezoid right here. We are looking for how much it takes to fill in that defined area right there. Okay, so today what we're going to be talking about is, all right, we're going to be getting into talking about surface area and volume, but surface area for different shapes. Now, when we talk about surface area, like what we're about to talk about, it is the total outside area of the three-dimensional object, okay? So, like what I mean is this, is if you were to cut this thing out, if you were to cut this whole shape out right here and fold it up, what do you think this would become? Okay, this would become a cube. Each one of these is a square itself. Yep. So the three-dimensional object would be a cube or a rectangular prism, or a regular rectangular prism. Now, if you were to fold this up into the cube, we want to know how much area is on the outside of this entire shape. And so what we're doing today is we are looking at what we call the net, okay, of this cube. So basically what a net is taking the three-dimensional shape and basically unfolding it. Okay, and where you can lay the whole thing flat. So what we're doing is we're just finding the area of each of the shapes, and then we're going to add all of those up. So it's really pretty simple. And to me, this is kind of the common sense way to do it, because we're going to have a whole bunch of formulas that we're about to be learning on all this. This is the common sense way to do it, is just to find the area of each outside piece and just add it up. So on this one, if each of these is a square 3 by 3, what would the area of each of these squares be? 9. Obviously, it's going to be 9, just length times width. Now, how many of those squares are there? There's 6 of them, right? So if each of them has an area of 9 square centimeters and there's 6 of them, what would the total surface area be for this? Yep. Take the 9 square centimeters times 6 of those, and that tells you that the total area is going to be 54 square centimeters. Okay, so on this one, if you were to cut this thing out and fold it up, what do you think this would become? Okay, rectangular pyramid. That would be fine. More specifically, we could say about that this one is a square pyramid, because you can see that both sides are 8 down here. So to make a square pyramid, I mean, there's more ways to do it than this, but this is the simplest way, is to have a square and then the 4 triangles here that would meet up at the top up here to make, where it comes to the point. And remember, we talked about this on Thursday and Friday. In a pyramid, it only has one base, and it has triangular faces. So what's the area of this piece right here, of the base? Yep, it's 64. 8 times 8. Okay. Now for the triangular part right here, we need to find the area of this. Okay, the 12 is talking about this right here. So this. Yeah, so let me redraw that over here just to. So this is 12. I'm going to drop a line straight down like this right here, because that would be my height. All right, and if this whole thing is 8, okay, right here, this is 8. If the whole thing is 8, how far is it from here to here? It's going to be 4. This would be 4 to add up to 8, but all I need is that 4. So what am I going to do to find the length of this side right here? Pythagorean theorem. Okay, I'm just going to do the kind of the shortcut. So 12 squared minus 4 squared. The reason I'm subtracting is I know the hypotenuse. So I'm just going to type it in just like that. 12 squared minus 4 squared, square rooted. What does that give you? Is what? Yep. So how am I going to find the area of that triangle now? Base times height divided by 2. So what's my base and height? 8 and 11.31. So I'm going to do 8 times 11.31 divided by 2. And what does that give you? 45.24. Okay. 45.24 is the area of that triangle, so it's going to be the area of all of these, same thing. So now to find the total surface area, I'm going to add up the area of each of those 5 shapes, the 4 triangles and the 1 square for the base. So I'm adding up 45.24 4 times, and then 64 once. What does that give you?
244 times.
There you go. Okay. On this one, if you cut this thing out and fold it up, okay, it's going to become some polyhedron. I forget exactly what that is. Well, this is going to be a dodecagon is what it is, because there's going to be 12. Yeah, so this is a dodecagon is what this will become. Anyways, well, no, not a dodecagon. It's a dodecahedra is what it is.
Yeah, you lost me at dodecagon.
Which, yeah, I don't have any of those. Anyways, that doesn't matter. The point of this is it tells us that the area of one of them is 20 square meters. So for every one of these, it's an area of 20 square meters. So this one's very simple because they've given us the area. So all we have to do is basically count how many of those there are. How many are there?
12.
Yeah, there's 12 of them. So each of them's 12. I mean, there's 12 of them. Each of them is 20. So what's going to be the total area of that thing? Okay, 240 square meters. Okay, number 4, if you were to cut that thing out, fold it up, what do you think that would become?
Cylinder.
Yes, this is the net of a cylinder.
Oh, I get it. That's kind of cool.
Okay, so the net of a cylinder has 2 circles and a rectangle. So let's find the area of the circles first. So how do I find the area of this circle? Pi r squared. Pi times 10 squared. Which is what? So that's the area of the 2 circular bases. Okay. Now I've got to find the area of this rectangular piece. Okay, I know the width of it is 8. So let's think about this. If you were to cut this out, fold it up, what's going to happen with this part? This is going to end up wrapping around the circle, right?
Yeah.
This is going to wrap to right there, and this side over here is going to wrap around until they meet up. So the length of this rectangle is the same thing as the circumference, good, of this circle. So to find the length of this rectangle, I need to know the circumference of the circle. How do we find circumference?
2 pi r.
Is 2 pi r, good. So 2 pi times 10 which is what? 62.83. Yep. So that 62.83 is the length of this rectangle right here. And we know the width is 8. So rectangle is just length times width. So 62.83 times 8. And so now to find the total area of that thing, we're going to add those 3 numbers up. 314.16 plus 502.64 plus 314.16. What does that give you? Yep. All right, next one. So on this one, what I have here is what the thing is in its 3-dimensional shape, and then with it unfolded. So what is this thing right here? Yep. This is a triangular pyramid. So it has 4 triangles. 3 of them are going to be the same. 1 is different. The base is going to be different. So let's find the area of the base first. Okay, so how are we going to find the area of this triangle? Good, base times height divided by 2. So 6 times 5.2 divided by 2. Which is what? Okay. So 15.6 is the area of that. Now to find the area of the other triangles, the other 3 will be the same. So on that one it has a base of 6, a height of 10. So 6 times 10 divided by 2 is what? Will be 30. So those three have an area of 30. The smaller triangular base has an area of 15.6. So what's the total area of that thing going to be?
105.
Okay. So what we're going to do is we're going to sketch the net for each one of these. All right, so on a cone, when you unfold the cone, it's kind of a weird thing, but it ends up being like this. It kind of got away from me. So something like that. Yeah, it should be even wider than that. Okay, so from here to here is 4, and this 8.2 is the distance from here to here. All we're doing on this is sketching it and labeling the measurements. We're not doing anything else beside that. Okay, on this one, for a rectangular prism, there's a lot of ways you could do this. I'm going to do it like this. Nope, there's going to need to be... Yeah. All right, so it's 16 from here to here, 19 from here to here, and this distance right here would be 6.